Lord Father, okay. Lord Father, I want to thank you for this day. Father, I want to thank you for your enabled us to turn up for this lesson. We pray that you put everything in this lesson into your hands, guide us to understand the teachers and the teachers to understand us. In your name we pray. Amen. Thank you.
Okay. Thank you so much, Mark, for the word of prayer. So last time we were looking at proving of trigonometric identities. I was happy. Some of you sent a lot of work that you had tried, which was very good, and a few numbers that have failed. But I was happy that at least members tried, and at least they were able to discover. So today, our focus still is going to be on another thing, but this thing is going to be what we call formulas. So our task today is going to be on formulae. For some of you have been seeing this sign of A plus minus B, cos of A plus minus B, and tan of A plus minus B. Now, what we are going to do today, this work is going to be very important for many of the topics you are going to be covering. You are going to use this knowledge in integration. When you do differentiation, you'll find the same knowledge somewhere. When you do the ease, you'll find the knowledge somewhere. When it comes to paper 2, you'll find the knowledge. So the topic of trigonometry has a wide application. Not only you will meet it in paper 1, but also you are going to meet it in paper 2. Those people who are doing physics, you are also going to meet it in physics. So that's why we always need to take it a bit serious such that we don't mess up. So now these formulas I know we are going to get them. We are not going to prove them, though I will show you some of them. I may be tempted to show you how they come about, but I'm not going to show you for some of these ones are standard. So the first one you need to know is the expansion. What happens when I have sine of A plus B? Now, this is the standard formula or a standard equation that whenever you expand sine, you always get sine A cos of B plus cos of A sine of B. That when you expand sine, when you have two angles, you always have sine of A cos of B, cos of A sine of B. Another one you need to know is that when you have sine and you are subtracting two angles and you expand it, what do you get? You'll have sine of A cos of B minus cos of A sine of B. When you have cos of A plus B, you'll have, now this is where you need to take the difference that in sine, when you are expanding the sines of two angles, you always have sine, cos, sine, cos. When you are expressing cos, here you always have cos of A, cos of B. And when it comes for cos, when it is a plus, when you are adding two angles, you subtract this side. So you have sine of A, sine of B. When you have cos of A minus B, this side you have cos of A, cos of B, and then you have a plus sine of A, sine of B. So the difference when you are subtracting in expansion, you add. Now, these ones are important formulas that we are going to be using for many parts of the trigonometry. Hope that is okay. Okay, thank you, Kelly. Yes, those ones are going to be very important when we are expanding. So please, you must master them. Are we together, members? Is that fine? Can we continue?
Yeah.
Okay. Okay. Now I'm going to scroll. Now, from these ones, you can be in position to obtain for tan. So what do you need to know is that when I have tan of A plus B, we know very well that tan is the same as sine of A plus B divided by, now for this case, divided by cos of A plus B. By definition, I know tan is given by sine out of cos, but since our angle is A plus B, also here you have A plus B out of A plus B. Now, what are you going to do? You are going to come and ask yourself, when I expand sine A plus of A plus B, what do I get? When we expand that, we shall have, you come from the first one here, that you get sine of A cos of B plus cos of A sine of B divided by, when you expand cos of A plus B, cos of A plus B is here. So meaning you have cos of A cos of B minus sine of A sine of B. Members, is that fine?
Yes, sir.
Okay.
Yes.
Okay. So when we continue, we are going to eliminate and we are going to simplify. So in order for us to simplify, we are going, since this is a tan, we want to express it in terms of tan. So what am I going to do? I'm going to eliminate cos A cos of B. Because in order for me to obtain tan, I must divide by cos. So I'll come to this expression. I remove cos A cos B. How am I going to do it? So I will say sine of A cos of B, the numerator, I divide it by cos of A, cos of B, plus cos of A, sine of B, divided by cos of A, cos of B. Everything, I'm dividing everything by cos of A, cos of B. What I have here, I have cos of A, cos of B, divided by cos of A, cos of B, minus sine of A, sine B, divided by cos of A, cos of B. The same thing you do like when you have a number. Let me say I have x plus 4 out of maybe 8 plus maybe 2. So here, in case you want to remove this 8 here, you can say by 8, every number of the expression by 8. So this is what we are doing. Now, when it comes here, I want you to be observant, to look and see that what happens is that now I have sine A out of cos A. Sine out of cos A is tan. Cos B and cos B will cancel. When I come here, cos A and cos A cancels. When I come here, this and the upper one are the same. When I come here, sine A cos A, sine B cos B. Yes, Trisha.
Excuse me, teacher. Why do
Yes.
you divide by cos A sine B?
Oh, I'm dividing by cos A cos B.
Like, why do you divide by cos A and cos B?
Oh, I want to create tan. I want to create tan in a simplified form. So in order for me to create tan, I must divide something by cos. And when you look here, the only thing which is having cos, it is only this time. So meaning it is the one that can be in position to eliminate what I don't want. I don't know that either.
Okay, thank you.
So you want to create a simplified expansion. But what you do, Trisha, feel free in your free time to try out and say, what if I divide by that? What will I get? So when we come here to the first one, we are remaining with sine A out of cos of A. For the next one, I'm remaining with sine B out of cos of B. Divide by, in the denominator, I'll have, here I have remained with 1 minus this side, I have sine A cos A, sine B cos B. So I have sine of A out of cos of A. I have sine of B out of cos of B. Now, one thing I know that sine A out of cos A is the same as tan, but the angle is A, plus sine out of cos is the same as tan of B. out of 1 minus sine A out of cos A is also tan of A. Sine B out of cos of B is tan B. And the whole of this one, members, will equal to our expansion we have done, which is A plus B. Now, this is another important formula that we are going to be using. So this is what we have been deriving. So I didn't want to just state it. I wanted to show you how it comes about, because you may find it in books and say, how did it come? So that's how it comes about. Are we together?
Yes.
Okay.
Yes.
Okay. Should we continue?
Yes.
Okay. Okay.
Yes,
Yes.
Okay. Now, in your free time, after the lesson, you'll go through the same procedure, and then you conclude that this one is also true. You do the same way we have done, and you come up with this. So this is your one of now the homework. We have started getting the homework. That is what you are going to try out to see how it comes about. First, expand that tan of A minus B is sine A minus B out of cos A minus B, and then you continue. Okay. Now we are going to start on some exercise, on some activity. So the first activity, these are just some examples that we are going to try out and say, find the values of the following. Find the values of the following. Now, in a trigonometry, I'm going to remind you always that in trigonometry, whenever you find, let me say, you find the 45, you find 30, you find 60. Those angles are special angles, and we don't expect you to write your points, those decimal points of yours. No, you must be able to give the exact value. Members, are we together on that? Whenever you find your solve, take an example. When they give us cos, now I have this, cos of 45. And the cos of 45, I'm dealing with it plus 30. Now, when you look at this one shows us we have two angles. This is like my angle A, and this is my angle B, and I'm adding two angles. What happens? I need to remember that cos of A plus B, when I expand, I'll have cos of A, cos of B, minus sine of A, sine of B. That is the expansion. Now, when you come here, you have those two angles. So I have cos of 45 plus 30. What will happen is that where there is A, I put 45. Where there is B, I put 30. So for this case, our A is 45, our B is equal to 30. Please do not cram. You can interchange. Your A can be 30, your B can be 45. You can interchange. So here we shall have cos of 45, cos of 30, minus sine of 45, sine of 30. Now your task is to simplify. Your task is to come and simplify. But when you look at 45 and 30, these are special angles. You need now to remember about special angles from, I think we did it in senior 4. When we talk about special angles, we are looking at those angles whose trigonometric ratios are known. So how do we come up with them? We know that one of the special angles is 60 and 30. And in order for us to get them, we have what we call an equilateral triangle. An equilateral triangle, we know that all angles are equal. So meaning all angles inside here are 60. Now, when I divide into the middle here, I'll have this side as 30. I have divided the angle into 2. And this one being an equilateral triangle, all the sides are equal. So meaning if this is 2, this one is 2, also this one is 2. In case this is 1, this will be 1, and also this one will be 1. Now, When you look at my equilateral triangle, from here up to here, it is 2. Meaning when I divide in the middle, members told me from where 60 is from this corner up to here, what distance shall we have?
1.
1, good. Now allow me to extract that triangle. I'm extracting that triangle where I have 60, I have here 30. So here we have remained with 1, here we have remained 2. Mathematicians, can we quickly find out what is the height for this right-angled triangle? I have 2 here, I have 1.
Root 3.
Root of 3.
Root of 3. Very good. Now we can start. In case I want, this is 30. If I want cos of 30, members, you go back to your SOHCAHTOA. You shouldn't forget SOHCAHTOA. That SOHCAHTOA, I have to get adjacent and hypotenuse. So for this case, if this is where 30 is, this is your adjacent and this is your hypotenuse. So members, our cos 30 will equal to what?
Root of 3 over 2.
Root of 3 out of 2. Very good. So when you look here, we have 30. What about sine of 30? What will it equal to?
Half.
Half, eh?
Yeah.
Good. Then similarly, we do the same for 45. For 45, still we shall come. So this one is 45. This one is also 45. Here 1, here you put 1. So what shall we have as our hypotenuse?
Root 2, I think.
This will be root of 2. Members who are not seeing how we are getting root 2, we are using Pythagoras theorem. 1 squared plus 1 squared is 2, then you get the root. So what is going to be our cos of 45?
1 over root 2.
1 out of root of 2. And what is going
Which
to
you can
be our...
rationalize.
Which you can rationalize. And then what is going to be our sign? 45?
Root of 2 over 2.
Root of 2 out of 2. Okay.
Yeah, rationalize already.
Okay, when you rationalize it, okay, good. The same thing happens with cos of 45. Let me hope, members, are we on the same page?
Yes.
Yes.
Okay.
Yes.
Now, okay, good. Now, I'll come back here where there is cos 45. We have got 1 out of root of 2, which is the same as root 2 out of 2. So I'll put root of 2 out of 2 times cos of 30, which we obtain as root of 3 out of 2 minus sine of 45, which we have as root of 2 out of 2 times sine of 30, which is 1 out of 2. Now, a root times a root, those two things can be multiplied. So I can multiply in case I want. In case I don't want, I can first leave them. So I have root of 2, root of 3, out of 2 times 2, which is equal to 4, minus root of 2 times 1 remains root of 2 out of 4. Now, when you look here, you can notice that 4 is common and root of 2 is common. So I can come out in the numerator, root of 2 is common, and in the denominator, 4 is common. So I can factor it out, and I remain with the root of 3 minus 1. And now that is what we call cos of 45 plus that. Yes, please.
So why are we using root of 2 over 2 for cos 45?
Cos of 45, eh?
Yeah, I
Like
thought
you
that
have 1
times
out
2.
of root of 2, eh? And you
Yes.
rationalize, eh? You multiply root of 2, root of 2. So 1 times root of 2 is root of 2. Out of root of 2 times root of 2 is root of 4. But root of 4 is same as 2. Hope you
Okay,
have
thank
got.
you.
Okay.
Yes.
Okay. Yes. Now, members, what do you need to remember? This is very important. Next time, here, just because we are building the concept, next time, they are going to tell you, show that cos of 75 is equal to root of 2 out of 4 into root of 3 minus 1. So they will bring it in this format. They say, show that cos of 75 is equal to that, and they put 5 marks. You need to know how it comes about. So it is up to you to look out for those angles that they add to get 75, or they subtract to get 75. But the moment you see things having root, the quickest idea that should come into your head is the idea that those things have to be dealing with the angles that are special. Okay. Or how did we get the one for the sides of the triangle? Linda say. Okay. Linda say you are talking about this?
Asking about the second triangle where we have 45 degrees.
Oh, okay. Now that one is also a special triangle. Yes. Do you know a triangle which has two equal sides? Which name do we give it? When two sides are equal?
Isosceles.
Isosceles. Yes. Now this is a right-angled isosceles triangle. These two sides are equal. Now, if the sides are equal, it means that the base angles here are also equal. And we know that in a right angle, we have a 90. So 90 plus, if these two sides are equal, this is x and this is x. So it becomes 90 plus 2x is equal to 180. And when you solve, you get x is equal to 45. So the angles here, we have a 45 and 45. So since these two sides are equal, for you, what you do, you use any numbers of your choice as long as they are equal. 2, 2, 4, 4, 6, 6, like that. But the easiest number that you can use is 1, 1. Why 1, 1? Because you may not need further simplification. So that's why we use 1 and 1. So in order for you to get this side here, the hypotenuse, then you go back, you say s squared plus b squared is equal to c squared. 1 squared plus 1 squared is equal to c squared, which is 2 is equal to c squared. When you get a root, you get this side as root of 2. Linda, are we together?
Yes, teacher.
Have you picked now?
Yes, thank you, teacher.
Okay. Yes. So please, you should know. In fact, even this same thing, they can also give it to you in another format. In case you had continued and you multiplied through by root of 2, your answer can become 1 out of 4, root of 6 minus root of 2. So they can as well tell you, show that cos of 75 is equal to this. So for you need to know how it comes about. Yes, Peter Chibero. Yes.
Are we done with that expression of root 2 out of 4 into root 3 minus 1? How did we get that 1?
1, like, are you seeing this part here? Let me put it in green. Are you seeing this part here?
Yes, I'm seeing it.
Yes. Are you noticing that here we have root of 2 here, and here we have root of 2? So there, it is a common factor. So that's why we pulled it out. So when we pull it, here we remain with the root of 3, here we remain with the 1. So is it fine?
Yes.
Okay. Yes. Yes, Swifty. Yes, when you are Swift, when you are adding cos and sine, you come back here. Swift, come back here from the general thing. When it is adding, you subtract the expansions. When it is subtraction, you add for coses, but not for sines. So that's where we picked it from. Okay, I think we can go on. So that is 1. So please, either you leave it like this or like this. So any format you have left it, they will mark you. But always at times they can specify. Okay, yes, Innocent.
Excuse me, sir.
Yes.
So where on the right angled triangle of 30 and 60, I'm trying to get root 3 as the height on that triangle, but it is not coming out really.
Okay. Remember, Innocent, you had 1, you had 2 here. Not so?
Yeah. Yes.
So this is what you want, height. So by
Yeah.
Pythagorean theory, this is 1 squared plus h squared is equal to 2 squared.
Yes.
This is 1 plus h squared is equal to 4.
Yeah.
So h squared will equal to 4 minus 1 when I take the one the other side.
Okay. Thank you, sir.
Yes, then you get the root.
Okay.
So we are trying another number. Now, another number, they want us to show that sine of 105, show that sine 105 is equal to root of 6 plus root of 2, everything divided by 4. Now, members, the moment you see these ones, the first idea should come into your mind. You must think about the special angles. After thinking about the special angles, you know you have 60, you have 30, you have 45. You ask yourself, is there any pair I can add to get 105? Is there something I can do when I subtract or I do something in order for me to use those angles to come up with 125? Members, are you not seeing something? Are there something we can do such that we get 105?
Yeah.
Yes.
What are you not
60
seeing?
degree, 45.
60 plus 45.
Very good. When you have 6 and 45, surely you get 105. So meaning that instead of writing sine 105, we shall write it as sine of 60 plus 45. Yes, Trisha?
Sorry to take you back, but what if I have such a question like find the value of sine 120 plus 45?
Oh.
And then yeah, I first tried finding cos, whereby from the triangle, from the isosceles triangle, my cos was root 2 over 2. And then now the sine 120 is one that is a bit confusing.
Sine what?
The sine 120.
Oh, now that one, we have another special way we can do it. When you find something bigger like that. Yes, so we are going to look at it. What if it is above that? In case you have something above that, you can do it in another way. You can still, now when you look at 120, when you look at sine 120, you ask yourself, which angles can you add that I can add 6 and 60? So where you are having, is it sine what? Sine 120, you can replace it with sine of 60 plus 60, and then you expand. Trisha, is it fine?
So it's just a matter of finding the two angles that can give you the answer.
Yes. Okay. Now, since here we have sine of 60 and 45, you must remember when we expand sine A plus B, what do we have? That I have sine of A, cos of B, plus sine of B, cos of A. Now, here you say your A is equal to 60 and B is equal to 45. So you substitute in. So you say sine is equal to 60 plus 45, which is equal to sine of 60 cos of 45 plus sine of 45 cos of 60. Now, once you reach here, these triangles we have come up with are going to be very, very helpful. You don't cram. I don't want you to cram, because the moment you cram, you may mess up with one of them and you get wrong thing. But for you, you can derive it in the paper, no problem. So that we know that is 60, and I know that one of 45. Here I have one, and then I have root of 2. So this is where 45 is. So members, what shall we put for sine of 60? I want you to look at your triangles. Sine of 60, what shall we have?
Root of 3 over 2.
Root of 3 out of 2. Good. Times cos of 45.
which is
2. Root 2 over 2.
Root of
1.
So people were getting 1 out of root of 2 is the same as 1 out of root of 2 times root of 2 out of root of 2. So which gives you root of 2 out of 4, root of 4, which is root of 2 out of 2. Now, always avoid having square roots in the denominator. Avoid having those surds in the denominator. Always rationalize such that you go away with them. So here we shall have sine of 45 is still root 2 out of 2 times cos of 60. What is cos of 60?
A half.
A half, eh?
Yeah.
Okay. So here we shall have root of 3 times root of 2, we get root of 6
6.
out of 4 plus root of 2 times 1 is what?
Two.
Out
Out of 4.
out of sorry,
4.
this is 4. So our common factor is 4. So meaning we can conclude and say the answer they wanted has come out. Root of 6 plus root of
That's
2
2 out of.
out of. Is that fine?
Yeah.
Yes. And whenever they tell you to show, make sure you come from that left-hand side, you go to the right-hand side. So you don't interchange. Yes, Robinson.
Yeah, sir. I just want to inquire something. The angles we are writing are not carrying the symbol degrees on them.
Oh,
One people can.
okay, you can put. It is very okay to put. It is very okay. You can put your degrees. It is very fine. It is very fine. But in case now, like, since the question didn't have, you can also ignore it. But it is a good practice to put.
Okay.
Okay. Innocent?
Excuse me, sir. I want to know that is it a must after stating it, let's say in A plus B equals to, and so on, then is it a must to state that let A equals to 30 and let B equals to 45?
It's not a must, as long
Okay,
as you know it.
yes.
Okay. We are doing another one. Still, yes, Mary.
Sir, I want to ask you whether, because you've told us that if they say show that we use the left hand side, and what if they say prove? You told us we can use either the right or the left from the previous lessons.
Perfect, Mary.
Oh, thank you.
Yes, that is perfect. Now, still, we have this one we are showing. Now, still, when you look at the angle, still the first idea should come from this one, 60, 45, 30. You ask yourself, is there any way I can obtain 15 using any of these angles?
Yes.
Yes. What do you do?
Subtract
45 minus 5 minus
from 45.
45 minus 30.
Okay, very good.
45 or 45 minus 30 and give 15.
Very good. So I will say 45 minus 30. Now, after reaching here, you know this is what we call subtraction of two angles when you have sine. Members, can we try everyone?
Yeah.
Okay. Yes. Let us try. Let us try and see whether it comes out very well. Okay. We are trying. Those who are just coming in, we are trying. We are trying. So let everyone first try. Oh, Saliba is asking, how do you know which one is A and which one? No, that one, for you, you just choose any of them to be your A and B. But the order now matters when you have a subtraction. Now, what if I use 45 plus 60? That is Kato Joseph. Kato Joseph, it is also very fine. You get the same answer. Because 45 plus 60 is 105. Teacher, is it okay for us to finish the number by adding root 6? Yeah. Oh, now Linda say, I don't know whether you are saying by doing root 6 plus root of 2, like adding 6 plus 2. I don't know that that's what you are meaning.
Yes.
And you get what? Like that you get root 8, something like this. So Linda said, this one cannot exist. You cannot add those two. Yes, so those ones you can't. So this one does not exist. So you stop there. Whenever you find that the two sides you have different digits inside the roots, you cannot add them. You can only add them when they have the same numbers. It means a root 3 inside. That one you can add them. Or when you can simplify to make it have the same roots. Oh, Stella has finished. Faith has finished. Nelly has finished. Okay. Good. Someone was saying, excuse me, teacher.
So what if we use 60 minus 45?
You use what?
60 minus 45.
60 minus 45. Still, you get the same answer.
Okay.
Yes. Even if you use 60, sine of 60, you'll get the same answer.
Thank you.
Is it what you are using?
Yeah.
60 and what? 45, eh?
Yes.
Okay. Still, you get the same answer. In fact, I can, let me just use this one. This is cos of 45. But those who have used 45 and 30, please continue. The beauty, you get the same answer. Okay, so sine of 60, I know, is root of 3 out of 2. Cos of 45, I know it is 1 out of root of 2, which I can write as root of 2 out of 2, minus sine of 45, which is 1, okay, which I can write as root of 2 out of 2, and then cos of 60, which is a half. So here, you remain with the root of 6 out of 4 minus root of 2 out of 4. So those who have used 6 and 45, also you should be able to come up with that answer. Okay. Members, are we good to continue?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. Now, we
Continue,
are going to, yes. Okay. Now, we are going to look at another version. Yes. Now, the second version we are going to look at when they have stated them and how we can go about it. Now, they're telling us that if sine of A is equal to 3 out of 5 and sine of B is equal to 5 out of 13, where A and B are acute angles. Find the values of the following. So, part A, the first one we are going to deal with, it's going to be sine of A minus B. It's the first one we are going to deal with. Now, yes. Yes, Nelly? Okay. Now, what are you going to notice? You first make your expansion. You say sine of A minus B is the same as sine of A cos of B minus sine of B cos of A. That is the first thing. But when you notice, you can notice that you have sine of A has been given the question. It is here. You notice you have sine of B, but you lack cos B and cos A. What you do, you go back and you remember your trigonometry. That sine of A is equal to 3 out of 5. But what is sine? We know that from SOHCAHTOA, sine is given by opposite out of hypotenuse. So when they write 3 out of 5, it means that this is the opposite and this is the hypotenuse. So you are going to first draw your right angled triangle and say, in case this is where my angle A is, my opposite is 3, my hypotenuse is 5. But remember, when I'm dealing with cos, I need the adjacent. So I find the adjacent for this angle. So can we find the adjacent? Use your Pythagoras theorem. And you tell me. It is?
4.
4. 4, good.
4.
4. Then we go to the next one, where we have sine of B. They told us that sine of B is 5 out of 13. But we know sine still is opposite of hypotenuse. So you draw your triangle. Put here your angle B. Your opposite is 5. Your hypotenuse is 13. Members, can we find the adjacent? Use Pythagoras theorem.
It's 12.
It is 12. Anyone failing to get 12 and those answers? Anyone getting sunshine? Are we good to continue, members?
Yes.
Okay. Now, when you reach here, we are going to extract our sine A, extract your cos B, sine B, and cos A. So we extract sine A, members. What do you have? Just look at your triangle. It's given by
Sine A is already there.
it's already there, which is 3 out of 5 times, you come, you check for your cos of B. Cos of B, you get it from here. So you know cos is the adjacent out of hypotenuse. So adjacent is 12, hypotenuse is done. So I say 12 out of 13 minus sine of B. I will come here. Sine of B is 5 out of 13 times cos of A. I will come here. Adjacent is 4 and hypotenuse is 5. So I say 4 out of 5. Members, is that fine?
Yes, sir.
Okay.
Yes.
Now, never rush for you to cancel out things. Take it slow. So multiply 3 times 12, what do you have?
36.
Out of 5 times 13?
65.
65. Good. And then we go to the other side. 5 times 4 is?
20.
Out of?
65.
65.
Since the denominators are the same, we subtract the numerators. 36 minus 20?
16.
16.
Out of?
65.
65. Can we reduce any further?
No. No.
So that is your answer. So you stop at that point. Now, what thing I have now, you need always even trade. Yeah? Since they told us in the question that the angle is an acute angle, we use the first quadrant. Because we know that in our quadrants, this is what we call the acute angle. We have the obtuse angle and have the reflex angle. So do not always forget that acute angles are between 0 and 90. So your triangle is always in the first quadrant. If they had said that where angle A and B are obtuse, then we would have drawn our triangle in this quadrant. In case that said that they are obtuse reflex, then we would have drawn either here or here. So always you need to know in which quadrant to draw, because those answers can vary depending on the quadrant where your angle is located. Okay. We continue. Yes, Robinson.
Sir, if like the angle is now obtuse, will the sign of given values change?
No,
Will it
sign,
change like to negative?
sign will change, but in the second quadrant, cos is negative, so cos changes.
Okay.
Cos changes to negative, tan changes to negative. Another question, or we continue, Robinson? Peter. Yes, Peter.
Teacher, is there a special name for angles in the fourth quadrant?
Yes.
Angles in the fourth quadrant.
So angles in the last quadrant, they don't have a special name, but any angle that is above 180, we call it a reflex, as long as it's above 180. They just have a general name. Except when you reach 360, now that one we call it a full angle. Yes. Have you seen the number you are trying out, members? Members,
Okay.
you are doing part B. You are doing part B. You are doing part B. Mark, are we on the same page? So everyone is trying out cos of A plus B. Sorry. So try, and then we are going to share our answers. In case you get stuck, you let us know. Anyone who has got an answer? Oh, we are still trying. Oh, let me check. 33 out of 65. 33 out of 65. Thank you, Mary. Thank you, Robinson. Is everyone getting that answer? Yes, okay. Angel Pete is saying yes. Okay, good. Members, should we just continue? Okay, try for me part C. Part C, tan of A plus B. Part C, tan A. Is there anyone who is lost on part B such that we do it? Anyone who is lost on part B and we hope? Okay. Yes, Trisha. Trisha?
What if the question came like it's saying find cosec A plus B?
Yes, even if it is cosec A plus B. In fact, I think we can find that. Now you need to know that cosec means what? 1 out of sine of A plus B. So now for you, what you do, you come here. Since at first we were getting sine of A plus B, I think. I don't know what we were getting. Was it A plus B? No, okay, it was A minus B. So for you, just get the reciprocal of the answer. Are you getting it? Okay.
No, you mean that if I get like
in case, okay, let me use cosec A minus B. Cosec A minus B means 1 out of sine of A minus B. Are you saying that? Now, since we have already obtained our sine of A minus B as 16 out of 65. It means that when you substitute here where there is sine A minus B, I will put 16 out of 65. So it will be 1 out of 16 out of 65. When this one goes, it becomes 65 out of 16. So it is just the reciprocal. Have you got it? Trisha?
yes.
Have you understood?
Yes.
So in fact here, you first do for me part C and we get our tan. Do not forget that tan A plus B, we must be able to get 1 tan A plus tan B out of 1 minus tan A tan B. So you substitute in that form.
So if I scroll up to the triangle, let's go back to the triangle.
The triangle. Here?
Yeah. There,
okay.
Yeah.
Okay. So we are trying, those are just, oh, I'm lost on part B. Kaka Junior. Oh, someone. Okay. Let me start with the last person. Mikova. These are the formulas we are using on the first screen. Those are the formulas we are using, those ones. Those are the general formulas. Then someone says he was getting lost. I think I wanted him to take me through how I was doing it. I don't know that you can. Okay, Swift has seen the mistake. Kato Joseph, so help me. Okay, Swift has seen the mistake. Oh, Kaka Junior, are you still on? Probably you can share and you see where the mistake is. Kaka Junior. Oh. Okay. But yes, Kaka. I think it was part B where you were getting yes, Kaka Junior, what you do, because we had cos A plus B, so still you do the same. You say cos A, cos B, minus sine of A, sine of B. Then you come back here to the triangles we had here. That cos of A, what is it? That cos is adjacent out of the hypotenuse. So it will be 4 out of 5. So here, I expect you to have 4 out of 5. Then you say, what is cos of B? You come here. Cos of B is adjacent out of hypotenuse. So it is 12 out of 13. So this is times 12 out of 13 minus sine of A. You come back here. Sine of A is opposite out of hypotenuse, which is 3 out of 5 times sine of B. Sine of B is 5 out of 13. Like that. So you come, then you multiply 4 times 12, that is 60. And then 4 times 12, 4 times 12, that is 48 out of 5 times 13, which is 65, minus 3 times 5, which is 15 out of 65. So when you subtract the 2, you end up with 33 out of 65. So probably it was the subtraction, something like that. Okay, so I'm waiting for turn B. Someone is getting 56 out of 33. 56 out of 33, 56 out of 33. Okay, 50, okay. Okay, 56 out of 33. Members, are we getting that? Everyone? But as members are trying, I'll come back here and also I start substituting as we wait for everyone to reach there. But you can look here and see where probably you are making the mistake. So we say tan of A plus B is the same as tan of A plus tan of B out of 1 minus tan of A, tan of B. So members, what was your tan A?
3 over 4.
3 out of 4.
3 over 4.
What was tan B?
5 over 12.
5 over 12.
5 out of 12. Out of 1 minus 3 out of 4 times 5 out of 2. Okay, good. Now, when I come here, I'll have 3 plus 4 plus 5 out of 12. That one will give us what?
14 out of 12.
14 out of 12. Sure?
Yes.
Yeah.
3 out of 4 plus 5 out of 12. So the LCM is 12, not so? Oh, okay. It is fine. I reduced already. So it is 14 out of 12. Yeah. Out of 1 minus 3 times 5 is 15. Out of 4 times 12, which is 48. Now, when you reach here, I'm going to first deal with the new denominator. I have 1 minus 15 out of 48. So members, what is 1 minus 15 out of 48? Okay. Or you can do like that. And you know that this is going to be 48 minus 15 out of 48 because the LCM is 48. So 48 minus 15 is going to yield 33 out of 48. So that means that in the denominator, in the numerator, I have 14 out of 12 divided by 33 out of 48. Now, when you do your mathematics, I have 14 out of 12. I'm dividing it with 33 out of 48, which will give me 14 out of 12 times 48 out of 33. So what is going to happen? I reduce. I know by 48 by 12, it goes there. So I say by 12, 1. By 12, 4. So I remain with 14 times 4 out of 33. And 14 times 4 surely will give us 56 out of 53. Thank you, members. That is very correct. Okay. Now, what are we going to do? And now we are going to continue. Yes. Now, for this same number, they could have asked you to find, let me say, quote of A plus B. Now, when they tell you quote, you know that quote means 1 out of 10 of A plus B. So for you, what you focus on is finding tan, then you get 1 out of that answer. In case that asks for quote. Members, if at all we want quote, what would be our answer?
33 over 56.
33 out of 56. You just make a reciprocal of your answer. Any question, members? Are we good to continue?
Excuse me.
Yes.
Can you please derive for me this formula of tan A plus B again?
Oh, it may take us time, but allow me to just show you and you take a screenshot. We derived it from here.
Okay,
Maybe
sir.
you came in a bit late.
Yes, sir.
Hey, but you will find it here. I will share. But in case you fail, then you let me know and we see how we can help.
Okay, sir.
Okay. Now, we are going to look at another question. We can have if sine of A is equal to 4 out of 5 and cos of B is equal to 12 out of 13, where A is an acute, yes, let me say, yes, A is an acute angle and B is a reflex angle. Find the values of, find the values of, find the values of Roman 1 sine of A plus B. Now, this one is testing for understanding. It tests whether you know those angles. Members, do not forget that now when you start trigonometry at A level, you must know that these ones, we call them acute angles, we call them obtuse angles, and any angle down here is what we call the reflex angle. 2, after you knowing that one, you come back again. You ask yourself, sine is an acute angle, meaning that when I'm drawing it for sine A, I will draw my triangle in the first quadrant. So my A will be here. Another thing to show you that it is an acute angle, because even sine here is given as a positive. So you ask yourself, sine is always given by opposite out of hypotenuse. So meaning your opposite for this angle is 4, hypotenuse is 5. Members, can we get the adjacent?
Yes.
It's 3.
It is 3. Are you saying 3?
Yeah.
Now, we know that, don't forget that all students, take chemistry? I think that's what you use. Now, when they talk about reflex angle, you take reflex angle, angle is lying between 180 and 360. And they told us that angle B is a reflex and it is cos. But even when I look at it, it is positive. I ask, is it lying in the second quadrant here or here? In which quadrant will it lie?
Fourth, I think.
Fourth. Why? Because when you look at the cos being given, cos of B is 12 out of 13. This is positive. So it is an indicator that now it's going to be in the third quadrant. So it is going to be here because cos is positive. If it was negative, you would have put it in the third quadrant. But since here it has been given as positive, it is in the fourth quadrant. So this is how you draw your thing. So I will draw again, and I put my angle, like this is my angle B. But I know katoa, it is adjacent out of hypotenuse. So I say my adjacent here is 12, hypotenuse is 13. Members, can we find the opposite?
I think 5.
5. People who don't know we are getting, it is just a matter of getting 13 squared minus 12 squared, which is, I think, 25, and then you get the root. Now, after you knowing this, the next thing you are going to know is during my expansion, we are going to expand that I have sine of A plus B. What will I get? I'll have sine of A cos of B plus I'll have sine of B cos of A. So I'll come, my read of A is here. Let me remove this. People may get confused. I ask myself, what is sine of A? Sine of A, we know very well, it is given by, this is always your opposite, this is adjacent and hypotenuse. Sine of A is opposite out of hypotenuse. So it's going to be 4 out of 5. Times cos of B, I come to cos. Cos of B is given by what? Adjacent out of hypotenuse, which is 12 out of 13. But cos in this quadrant is positive, so that's why we take it as a positive. I come plus sine of B. I will come sine of B. Sine of B in this quadrant is given as opposite, which is 5, out of hypotenuse, which is what? 13. But in this quadrant, sine is what? Negative. So I'll put here negative. Members, are we together on that?
Yes.
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 So here I put negative 5 out of 13 times, I come back to cos A. Cos A, this is the first quadrant, all of them are positive. So I will say, what is cos of A? Cos of A is given by adjacent out of hypotenuse. So I'll say 3 out of 5. Are we still together, members?
Yes.
Yes, sir.
Mister, okay. Mister, do you have a burning question? Okay. So you multiply, 4 times 12 is 48 out of 5 times 13, which gives us 65. Now this one is going plus and a minus is a minus, 5 times 3, which is 15 out of 65. So you will say 48 minus 15, you end up with 33. So here our final answer is going to be 33 out of 60. Members, have we understood that?
Yes.
Okay, we can be right. Mr. Unmute. Mr. is failing to unmute. Mr. Okay. Okay. Now it is your turn also to try out yours. Now the one I want you to try out. Yeah. So here I want us to do cos of A plus B. Okay, let me leave you now to try. Try out cos of A plus B. Mister, your background is bad and you are not talking. So everyone is trying out cos A plus B. I think I can score it. I'm trying to try and see what we get. Not forget those signs, and those signs will be so helpful when you are finding angles during solving of the equations. Anyone who has got the answer?
Yes, for me I have 56 out of 65.
56 out of 65. Okay, good.
Yes.
Okay, thank you. That is good. Any other?
I also have 56 out of 65.
56 out of 65. Okay, that is good. Okay, the same? Anyone getting something different?
No.
Okay, okay. Okay, okay. I think John has just come. Okay, 56 out of 65. Good. That is good, and that is our answer. So anyone having that answer here, that is very good. Okay, now we are going to advance. We are going to advance and do now one that involves applying the knowledge. Okay. Now, at times, we are going to...
Excuse me, sir.
Yes, please.
I'm having a problem getting the answer there.
The same.
May you please help me? I'm getting 16 over 65.
So it's the same. I'm also getting 16 out of 65.
I'm
Okay.
also getting 16 out of 65.
Okay.
Yeah.
Okay. Okay. Kindly, you people, you are the one to take us. Who's taking us? I saw Joanne, I saw Dylan, Nelly. So when you expanded, what did you get? Did you have this?
36 over 65 and negative 20 over 65.
Okay. Tell us, what was your cos A?
My cos A
3
was
over
3 over 5.
What is cos B?
12
over
13.
13.
Minus. What is sin A?
4 over 5.
4 over 5.
What is sin B?
Negative 5 over 13.
Negative?
5 over 13.
Yes. So 3 times 12, you got 36.
36.
Out of
65.
And now, okay, first leave this negative. 4 times negative 5, you get?
Negative 20.
Out of?
65.
So here the LCM is 65. So here you have 36 minus
teacher,
minus.
You've seen the mistake.
Minus minus.
Yes. Yes.
Okay.
Excuse me, sir.
I've seen my mistake.
Whenever sign is not in its quadrant, it's supposed to be negative.
As long as it is not in the first and the second, it must be negative.
All right. Thank you, sir.
Okay. Okay. We go to the next one. We are going to work out. They can tell us. Okay. I think I say we are going to say show that. Show that. Should I use this? Okay. Okay. I want it. Okay. We are going. Let us use the show. It is also okay. We are going to say show that. Show that. I'm trying to see what there's something I want. Okay. Okay. I think, okay. Let us not say show that. I will bring that one as part of the exercise. Okay. I'll bring it as part of the exercise. So just let us just say, if tan x plus 45 degrees is equal to 2, find the value of tan x. So they can also give you something like this. They tell you, if tan of x plus 45 is equal to 2, if the whole angle is x plus 45, what is tan only? Now, here they are looking for the way you are able to expand. So you have to remember that we say that when you have tan of a plus b, this one is the same as tan of a plus tan of b out of 1 minus tan of a tan of b. So what are you going to do? Now, members, I want you to apply that one on your left-hand side. And tell me the simplified thing you are going to remain with. I want you to apply this on one side. And you tell me the simplified version you stay with before you equate to 2. Have you got it, members? Have you understood?
No.
Not yet, eh?
No.
Okay.
No.
Okay. We know when we expand tan of x plus 45, we shall get tan x plus tan of 45 out of 1 minus tan x tan 45 is equal to 2. Is that one clear?
Yes.
Now, when we go back to our right angled triangle where we had 45, 1, 1, what is tan of 45?
1.
1. So meaning where there is tan of 45, we shall say plus 1 out of 1 minus tan of x times 1 is equal to 2. Is that one fine?
Yes.
Yes.
Yes. Now, what are you going to do? Once you reach this point, you can cross multiply. So when I cross multiply, I'll have tan x plus 1.
Excuse me, teacher.
Yes.
The question is not clear.
Oh, the question, eh? Okay, now the question is, they want you to find what is tan x alone. Well, they have given you x plus 45. This is a full angle. So they have told you that if you have x plus 45, tan of that is equal to. What about only tan? What is it equal to? So our task is to find out what the weight of tan x alone. Because here they have told us that when you have that x plus 45 tan, you get 2. What about only tan? What do you get? Are you getting it? Not yet.
Getting it.
Yeah, so that is what we are. So our task is to find out tan only. So when you cross multiply, you get this. So half tan of x plus 1 is equal to 2 minus 2 tan x. Members, are we together up that step?
Yes.
Yes.
So we are going to take the tan this side and say tan of x plus 2 tan of x is equal to 2 minus 1. I'm bringing the 1, I'm taking the 2 tan x. Are we on the same page there?
Yes.
So tan x plus 2 tan x, what do we get?
Get negative tan x.
Huh?
3
Tan
tan
Get
x.
3 tan x.
3 tan x there
Yes.
is
Yeah.
equal to 1.
1.
So meaning that to get tan x, you divide by 3. So I will say tan x is equal to 1 out of 3. So that's what they wanted you. So they wanted you to find the value of tan x. Are we together?
Yes,
Yes.
sir.
Okay. Okay. We continue?
Yes.
Okay. Let me give you another one. Are we there, members? I want to give you one more.
Yes.
Yes, sir.
Yeah.
Yes,
Okay.
a hard one.
A hard one. Okay.
Yes,
So
sir.
I have this. I want you to try for me this. Tan. I have tan x minus 2 is equal to 3 out of 2. But, okay.
What are you finding?
Yeah, okay. Let me make it better. Can allow me to make it better? Put here a. So it's going to be, I want you leave it tan x minus a is equal to 3 out of 2, where tan of a is equal to 2. Yes, find tan x. Have you got?
Yes, sir.
Okay. Make your expansions, but where there is tan a, you put 2.
Excuse me, sir.
Yes. People
I'm
have the
having
answer ready.
I'm having 7 over 8.
7 out of 8, eh?
Yes.
That's what you have. What about other
7
people?
out of 8.
7 out of 8.
Negative 7 out of 4.
Negative 7 out of 4. I think
7 out of 8.
I think we prove. I want someone of 7 out of 8 to be the one to take us through. Who has 7 out of 8? Take us through. Anyone, Innocent, take us. And we start with 7 out of 8.
So now, teacher, tan x minus a is the same as tan a minus, is the same as tan x minus tan a over 1 over 1 minus tan x.
I think
tan
that's
a.
where you started. When it is minus down, it is a plus.
Okay.
So that's how you got 7 out of 8. So members, anyone getting that is, I think, the mistake. Negative 7 out of 4. Yes. Negative 7 out of 4. Okay.
Thank you, sir.
Okay. Let me hope people who are getting that one have seen where the mistake was. Yes. Members, are we good to continue? You can finish and prove that your tan x is equal to negative 7 out of 4.
Yes.
Okay. Okay. I think we are going now to continue applying. And now we are going to apply proving identities. And now, last time we looked at proving some identities, and now we are going to look. And we are going to say, prove the following identities. Prove the following identities. So the first one, I have sine of a plus b plus sine of a minus b, prove that is equal to 2 sine of a cos of b. Is that fine, members? Now, these numbers, whenever you look at a proof, please don't fear, say, something is very hard. No, or you approach it. Now, when we expand sine a plus b, we end up with sine a cos b plus sine of b cos of a. Is that fine, members?
Yes.
Plus, we work out this one. What shall we have?
Sine A cos B
Minus
sine
A cos B.
sine B cos
B.
That's so?
Yes.
Yeah. Now, when you look inside, are you noticing something cancelling? Something common?
Yes.
Are you noticing this one and this?
Sine B cos A.
A. So are you noticing that they can cancel the two?
Yeah.
So I remain with sine A cos B.
Yes,
Plus sine A cos B. So since they are the same, when you add their two, there is a silent one, there is a silent one. So you end up with 2 sine of A cos of B. Are we together, members?
Yes.
Yeah.
Okay. Okay. I think, let me also, in the same vein, on this number, part 2, let me challenge you and you prove for me this one. You prove that sine 2A is the same as 2 sine of A cos of B. You try. That is the second identity we are proving.
But so where is B coming from?
Oh, sorry. This is A. This is A. Sorry. When you discover it after getting it right, please you tell us.
Yeah, it's coming.
It's coming? Charlotte, is it also coming?
Yes, teacher.
Kindly give us a hint.
So sine 2a is the same as sine A plus sine B.
I beg your pardon?
Sine 2a is the same as sine A plus B. Sine A plus A.
Good.
So when you open the bracket, you get sine A cos A plus sine A cos A, which is the same as cos A, sine A. 2 cos, sorry, 2 sine A cos B, cos A.
Okay. Members, please take note of this identity. Put it, in fact, this one, you put it in your head. It's going to be very common, more so when it comes to proving. That one is also an important identity. Yes. So now those people who are talking about double angles, that's what we call the double angle. That's what we call the double angle. And from there, we can derive very many. Why don't I challenge you? For me, I've started to dig deep. Let me start digging deep now. Members, find cos 2a.
This is
In fact, let me challenge you also this one. Show that cos 2a is 2 cos squared a minus 1.
It's 1. Oh my God.
Now, this is the real trigonometry. And once you understand these ones, things are going to be very, very easy.
Okay.
Hey, again, Charlotte, you have discovered?
Yes, teacher.
Hey, that is good. Give us a hint again. Charlotte, we are waiting for you. Oh, Charlotte, we are not getting that. Robinson?
Can I give a hint?
Yeah.
Okay. Cos of 2a is the same as cos of a plus a. And when we expand, we get to cos of a minus sine of a, sine of a. So when you continue, it becomes cos squared a minus sine squared a. But then looking at the given expression, we have cos squared present. So that means we need to change sine squared to cos squared using the identity sine squared plus cos squared equals to 1. So that means we will end up with sine squared a being equals to 1 minus cos squared a. And when we now go back to the expression we had, so we'll have cos squared a minus into bracket 1 minus cos squared a. And in the next step, we can open that bracket, which give us cos squared a minus 1 plus cos squared a. So we end up with 2 cos squared a minus 1.
Thank you. Members, this is another identity. Are we still on the same page or we are leaving some people behind? Anyone that is lost, are we on the same page? Oh.
So me, I'm lost.
Okay, from where? The whole thing?
Yes.
Okay. Yes. Now, what you need to remember is that when I have cos, we are building from this idea that cos A plus B is cos of A, cos of B minus sine of A, sine of B. Now, what we have is cos of 2A. Now, your idea should be, how can I express it in form of A plus B, the way we have been doing with angles? So it means that to get cos 2A, you can have A plus what? A. And now you substitute where A is A. Your B is also A. So you get cos of A minus sine of A, sine of A. I don't know that the person who is lost will be on the same page.
Yes, we are.
Now you ask yourself, cos times cos gives us cos squared A minus sine times sine gives us sine squared A. But now, since we want to now, members, you're going to allow me now this one to put it in the sine format. Now, we know very well that sine squared A plus cos squared A is equal to 1. So in case you want to either sine or cos, it is up to you. But now I want sine.
Excuse me.
Yes. Yes. Yes.
Sine squared A plus cos squared is equals to 1.
That is identity. It is an identity in trigonometry. It is what we did in the first lesson last week.
Okay.
Yeah. So that one is a standard thing. I showed them how it came about. So you should just know it, that whenever you have sine squared A plus cos squared A is equal to 1. But don't take it is, even if the angle is different, even if I have cos squared 2A plus sine squared 2A, also I get 1. As long as the angles are the same. Even if I have 8A, 8A, even if I have cos squared 100 plus sine squared 100, still the answer would be 1. Are we together?
Yes, sir.
Okay.
Yes.
Now here I wanted us to put it in terms of sine. So meaning I'll eliminate cos and I say cos squared A is equal to 1 minus sine squared A. So I'll come here and I say 1 minus sine squared A minus sine squared A. So this one will yield 1 minus 2 sine squared A. So meaning that your cos of 2A will equal to that. Yes. So that is also an identity. So please, those ones, in case it is in sine, you write it there. In case it is in form of cos, then you need to know it is given as 2 cos squared A minus 1. And these ones are very important when you are solving. They are going to be telling you to solve a trigonometric equation. Maybe that is for next week. And what you'll find things like this. They say solve cos 2A is equal to maybe plus 1 is equal to something like that. So you need to know that when you are solving, you bring in those ones. Yes. So that one we shall leave for next week. Are we now together? Are we together, members, or not yet?
We are together.
Yes, we are.
Okay. Okay. I am giving.
Yes, sir, we're together.
Okay, yes. Annie Grace, you can unmute.
Teacher, for the previous part, can't you just what if you substitute for sine squared A instead of substituting cos 2A?
Then when you substitute for sine A, you'll end up with 2 cos squared A minus 1.
Oh, okay.
So it can either be in form of sine or in form of cos. It depends on what you have substituted with. Okay. Let me allow you to do for me this one. Tan A plus tan B, prove that it is the same as sine A plus B out of cos A cos B. I know the heads are boiling. That is good. Okay, Swift, I will send them. Yes, Innocent?
Yes, I have booked
Can I
it.
take you through?
Okay. Who has not said it? Miss Onde, who has not said anything?
Innocent.
Charlotte. Okay, Charlotte. Okay, Charlotte, take. I think Charlotte has not said.
Charlotte said already.
Hey. So
Yeah.
Innocent. Okay. Okay, Innocent, tell us one step, and also Charlotte tells us one step.
Okay,
But
sir.
maybe
Tan theta, tan theta, okay, tan theta or tan anything is the same as sine over cos. So in this case, tan A is the same as sine A over cos A. Then plus sine A over plus sine B over cos B.
Yeah.
Yeah. Should I add on?
Charlotte, take us from there. Okay, thank you, Innocent.
So we are going to multiply through by the LCM, which is cos A cos B.
Yeah.
Cos A cos B. After multiplying through by the LCM, we get sine A cos B plus sine B cos A.
Yeah.
But if you look at the numerator, it came from an expansion, which is sine A plus B.
Okay.
Out of cos A cos B.
Okay, that is very good. Thank you. Now we are going to do. Oh, members, should we continue?
Yes.
Yes.
Okay, we are going to do 2 more to close off this session, and I'm going to give you the ones that you are going to be enjoying in the evening.
Excuse me, sir.
Yes.
Teach about the previous example.
This one, eh?
Cos. No.
Cos
Cos 2A. Cos 2A. Teacher, if you change that sine squared A, this step of cos squared A minus sine squared A. Teacher, have you seen there?
I'm seeing.
If I change the sine squared A, I'll get 1 minus cosec squared A. Not so.
No, cosec from where? Remember, to get cosec.
No, I'm saying cos, not cosec, sorry. I'll get 1 minus cos squared A.
For sine squared, yes.
Yeah. And
Okay,
then
yeah.
I'm seeing like I'm having a positive 1 and a negative 1.
Where? Here?
So I'm
when
confused.
You substitute for sine?
Yeah, there.
So negative times 1 is negative 1. Negative times a negative is positive. So Chibera, are you getting this?
Teacher, first wait. Yeah, teacher. Thank you.
Okay. Okay. Members, we are proving this. Prove that tan 2a. Prove that tan 2a is the same as 2 tan a out of 1 minus tan squared a. Yes. So someone was asking for the hard one. But this one may not be so hard, but it can be doable. Oh, Saliba, should I go back? Saliba, you let us know.
Excuse me, sir.
Yes.
I got the answer.
Good. This is so
I've also
interesting.
got it.
Who has not said anything now? Putula. Also,
Kauthara.
Katha. Okay, Katha. Yes. Take us.
Kauthara.
Okay, that one. Take us through.
Yes, so tan 2a is the same as tan, open brackets, a plus a, right?
Yes.
So we shall have tan a plus tan a out of 1 minus tan a tan a.
Out of 1 minus tan a. Okay, good.
So 2 tan a
Mm.
out of 1 minus tan squared a.
Okay, good. Thank you.
Welcome.
Hope everyone is okay with that. Is that fine, members?
Very fine.
Okay. So we are going to expand a bit. Now we are going to prove the ones of sines. Please don't let us leave you. Show that sine 3a is equal to 3 sine a minus 4 sine cubed a. Are we trying it first?
Yeah.
Okay. Oh, patience. Patience.
Can I take it through?
Who has the answer?
Charlotte.
Charlotte. Okay. I think Charlotte, we can start as other members are.
So we have what? Sine 3A. Sine 3A is the same as sine 2A plus A. And when we expand, we get sine 2A cos A plus cos 2A sine A. So we can also try to expand sine 2A, which is going to be 2 sine A cos A. Times cos A. Then plus sine, remember we had sine 2A is the same, cos 2A is the same as 1 minus 2 sine squared A times sine A. So we get 2 sine A cos squared A plus, so we're going to open the brackets and it's going to be sine A minus 2 sine cubed A. But then here we have cos 2A, cos squared. We are going to make it 1 minus sine squared A since we need the answer in form of sine. 1 minus sine squared A. Then plus sine A minus sine cubed A. So we are going to come up with 2 sine A minus 2 sine cubed A plus sine A minus 2 sine cubed A, which is 3 sine A minus 4 sine cubed A.
Thank you.
You're welcome.
Yes, how many people had gotten up to that point?
Yes, it came.
I'm also lost somewhere. Okay, So those people got lost from where? Those people who got lost.
The third step.
The what? Third step there. The third, 1, 2, here. From here?
Got lost from the first part.
Okay. Let us repeat it once. Now, when we have sine of 3a, now it is up to you. You know.
I think I got lost in the first part.
Okay. Now, what you need to remember is you ask yourself, how can I generate something from sine 3a? You have noticed that we have been dealing with double angles. We looked at sine 2a, and remember, as you proved it, that is the same as 2 sine a cos of a. We have looked at cos of 2a, and you proved it that it can be 2 cos squared a minus 1, or it can be cos of 2a. It can be the same as 1 minus 2 sine squared a. These are what we proved. Now you ask yourself, if I have 3a, which kind of relation can I derive? So the common relations you are going to notice is that using double angles. Whenever you have a triple angle, bring a double angle. And since we are supposed to add only 2 angles, then it means that for anything you are doing, make sure you come up with 2 angles. So the easiest one to obtain 3a is us getting 2a plus a. But still, some people even can use 4a minus a. But you ask yourself, even this one, by the way, it can lead you to the answer. When you use 4a minus a, it can lead you to the answer. as long as you know how to deal with double angles. So now when you come here, you go back to our expansion that when I have sine of A plus B, this is the same as sine A cos B plus sine of A, sine of B cos of A. This is what we are going to apply here. Now I'll come and I say now I'll have sine of 2A cos of A plus I will substitute here sine of A cos of 2A. Now, when you reach that step, remember from this identity, in case you don't remember, for you to derive, go back and simplify and say, I have sine 2A, which is the same as sine of A plus A. You repeat in case you have not, but like I told you, this one must be on your head going forward. So I'm going to substitute where there is sine 2A, I put 2 sine A cos A. So I'll say 2 sine of A cos of A plus sine of A. Now you remember your answer, what they want you to prove, has only sine, meaning cos of 2A. I can also go back and expand the same way here. Cos of 2A is the same as cos of A plus A. But since I know it already, from here, I'm going to just put. So I'll put here 1 minus 2 sine squared A. Members, are we together up that point? Are we together?
Yeah.
Okay.
Yes. Yes.
Okay. So now we shall go and have 2 sine of A. Then cos A times cos A is the same as cos squared A. Plus, you open your bracket. Sine A multiplies there. Sine A multiplies there. So you have sine of A minus 2 sine of A sine squared A. So this will give you 2 sine of A cos squared of A plus sine of A minus 2 sine of cubed A. When you look at what you are remaining with, the odd man is cos squared A. Now you come back again to the identity. Sine squared A plus cos squared A is equal to 1. What is related to cos squared A? I make it the subject. I say it's the same as 1 minus sine squared A. So I'll come back and say this is 2 sine of A. Where there is cos squared A, we put that. 1 minus sine squared A plus sine of A minus 2 sine of cubed A. So you open brackets now. So you have 2 sine of A minus 2 sine cubed of A. Do not forget that that outside sine, this one, the whole of this one, will affect this. The whole of it, it will also multiply there. Now, after noticing that, you continue. Plus sine of A minus 2 sine of cube A. Now, this sine A and the 2 sine A are like terms. So this is 2, this one has an hidden 1. 2 plus 1 gives us 3 sine of A. This is minus 2 minus 2, which gives us minus 4 sine cubed of A. And therefore, sine 3A is equal to that. Members, have we picked something?
Yes.
Yeah.
Okay, Yes, Peter Chiberu, a question?
Master, I'm seeing 2 sine A. Yeah, there is where you multiplied sine
Here.
A and sine A. Here, up. Yeah, there. Where is the other cosine A coming from?
This one, this cos A.
Yeah, there is a second cos A.
Now, the whole of sine 2A, it is the same as 2 sine A cos A. Chiberu, when we go back, there is an identity we proved here. If you can come back where? Here. Do you remember this? From here?
Yes.
So where there is sine 2A, it is the same as 2 sine A cos A.
Yes.
So that's why we substitute it. Have you got?
Yeah, and I'm saying, teacher, there is a second one down here.
It comes from here. Cos of A is here. Now, when you come here, cos A times cos A is like having x times x, which is x squared. Okay. I think that is it. Redmi. Seems Redmi, you have a question. Oh, Redmi has just joined. It's a bit tough for Redmi. Now, I think what I'm going to advise, those who have just come in, maybe today has been your first lesson. What we are going to do, I will repost the first video in the chat. And then you first try to go through that trigonometry because we are building, meaning that you need to have a foundation in order for you. And more so if at all you have come into this lesson a bit late. Yeah, but in case you fail to understand that video, then you let us know and then we'll prepare and see what we can do. So now allow me to give you the exercise. The first, yes. So the first, our exercise for today, and please don't forget what we said that for math, now like we have learned a new concept. Make sure that by the time you go to 3, you have done your 5 numbers. After the 5 numbers, just send me a hi, just send me a screenshot or just a photo that I've finished my 5 numbers. Now that one will show you that you at least you have picked the idea. So my first one, I'm going to give you
Apa? Oh.
this one. We are going to, this is from UNEB. It says, the acute angles A and B are such that cos A is equal to a half, sine of B is equal to a third. Show without the use of table or calculator. Show that Momo, show that tan A plus B is equal to 9 root 3 plus 8 root of 2 out of 5. Then 4, still this is UNEB, without using tables or calculator, evaluate, let me say show that tan 15 is equal to 2 minus root of 3. Are we still on?
Yes.
Yes.
Yes,
Yeah.
teacher.
Yes.
Yes, sir.
Yes, sir.
Okay, good. Those are 4. I promised you 5 at least. If tan plus b is equal to 1 out of 7, and tan a is equal to 3, find the value of tan b. And the value
Okutawulira. Okwenda tulole mu kizimba.
of the values for
Ndi mu kumalira.
members, that is enough for today. Unless someone has a question. Momo Dennis, any question?
Yes.
Yes, Momo.
Just
Yeah?
scroll down. I've not finished number 4, question 4. Yeah.
Question 4. I scroll down.
Yeah.
There.
Thank you, sir. Yeah.
Someone is telling me the group is full. Let people finish and we'll pick the link maybe. Yes, Innocent.
Sure, I'm asking that, are we going to be sharing these holiday lessons for every holiday?
Yes, unless something comes up. But we have been running it like that for, I think now for the past 5 years.
Okay. Okay, thank you, sir.
Okay. Peter and Mary.
Teacher, the link. Don't
I would
forget
like
to
to
share
ask,
the link.
are we
Okay, let me get it. You have said group A is full.
Yes.
Okay.
Yes.
Those who have finished, feel free to drop off. Can I stop the sharing? I have shared the link, those who are not there. I think I can stop the sharing. Okay.